Alright, so I'm going to be going over basically a review of everything I've already done with the variables, movement, load levels, all that. But I'm also going to be explaining the four principles of object-oriented programming. The first one being abstraction, which is basically one like something should know the details. Like one class shouldn't know the inner details of another in order to use it. Just knowing the interfaces should be enough. So you don't really need to know everything about it, every single detail, but as long as you like knows just small things. Like it's a little difficult to explain, but I think I should be able to just showcase it. Like for example, with the with the camera. Like I don't need to know, like the class doesn't need to know everything about the camera in order to use it. It can just use it, you know. The next one will be inheritance, which is literally just inherits from another class, which is basically what I already did with the blueprint classes right here with the health, player health, and all that. So I could just drag. So like no matter what, if I make a new blueprint, I could just drag health in there. It'll automatically have the health component because it would inherit from that class. So everything that health has will get passed down to whatever I put it into. So like with the sprite, if I would add health to like a different sprite, it would inherit that and have a health bar as well. So polymorphism, basically, it's also pretty related to like inheritance as well, but it's kind of like a super class, like a big class that like kind of like oversees all the other ones. This one's like I guess the best way to describe it maybe would be the game instance, as everything has to abide by the game instance that's in here. And then, here we go. Encapsulation. It's hiding data by restricting access to public methods. Basically, you can go into here, and there's like variables and stuff on the side, components that you can make public, but you can also hide. So encapsulation is simply hiding a lot of the big stuff. So like, for example, I've turned hit check. I turned it into a function that I could just call, so I don't have to like. It has a whole bunch of code in here, but like not everybody has to see it. So like it's just all in there. That is basically the meaning of encapsulation. So I guess I'll just showcase movement again. I'll just review my movement and then the load level and basically everything I have in here really. So yeah, so I got the movement, which is using vectors, which basically just uses kind of math to like calculate the distance from me and basically subtracts that distance to make it move. And then of course the spawn destroy actors. Like when I touch it, it destroys. And then when I die, also closely showcasing the die and reload level as well. Oh, like that, like right there, I accidentally pressed it too fast. But so the data does persist due to with the game mode, and the video explains. Yeah, so basically, it's really useful to use a whole game instance, so you don't have to constantly keep writing individual code for everything. So it's like with my game mode, basically, the data gets stored in there. So like it stores my lives, it stores my points, and all of that. So even though the level resets, my points are still there. Let's see what else. Collisions and overlaps. Yeah, I already showcased that. input actions. Yeah, I did showcase those. Showcase. Yeah. And key events. So yeah, key events are like events that basically trigger when you press a key, and input actions are just like things that like, let's say I press a button and like I shoot a fireball. That would be like an input action. Well, like if I press a button and a cutscene plays, that would be a key event. Um, yeah, showcase basically everything the UI. All right, yeah, that's basically it for this video.